Good morning, afternoon, evening. An important Viva question we are going to discuss that relates to a disaccharide, the non-reducing disaccharide that is sucrose. So we are going to see why it is called a non-reducing sugar. Number two, why sucrose is called invert sugar. First, non-reducing. Reducing property of any sugar is because of a free functional group, free anomeric carbon atom. For example, glucose, it has got a free functional group, the anomeric carbon atom C1, it has got an aldehyde group. So that imparts reducing property to it. Fructose, again, it is reducing sugar because it has got its functional group. It is at C2, carbon 2. It contains a keto group. So free functional group, a keto group. So therefore, fructose is also reducing. Now consider what happens in sucrose. C1, the aldehyde group of glucose is linked by a glycosidic linkage to keto group of fructose. So both the anomeric carbon atom, or simply stated the functional groups, aldehyde of glucose, keto group of fructose, are involved in a glycosidic linkage. So they are no more free. अब वो free नहीं है, being involved in a glycosidic linkage. As a result of which, sucrose is non-reducing in nature. I repeat, because it does not have got a free functional group. The anomeric carbon atom of both the constituents glucose and fructose are involved in a glycosidic linkage. A question for you, why sucrose gives Benedict test as negative, whereas maltose and lactose give it positive? A hint, Benedict test detects reducing property of a sugar. So we answer the first question, why sucrose is non-reducing in nature. Second question, why it is called invert sugar. Sucrose is dextrorotatory in nature, means when the plane polarized light is passed through sucrose, it is rotated in the right direction. दाएं हाथ को. Look at my right hand. Sucrose rotates the plane polarized light in the right direction. But when sucrose is cleaved into glucose and fructose, now glucose and fructose both have got different optical activities. Glucose is still dextrorotatory, whereas fructose is levorotatory, very strongly levorotatory. The levorotatory action of fructose is much more than dextrorotatory action of glucose. The net effect is that the mixture, because of strong levorotatory activity of fructose, the mixture is levorotatory. Now we go to the beginning. Sucrose, dextrorotatory. After cleavage into its two constituents, monosaccharide units, it becomes levorotatory. Dextrorotatory to levorotatory. So sort of inversion. So that is why it is called invert sugar. And sucrase, the enzyme which cleaves sucrose into the two constituent monosaccharide, glucose and fructose, it is accordingly called invertase. So sucrose, invert sugar, sucrase, invertase. So non-reducing property we have discussed because there is no free anomeric carbon atom. And invert sugar because of inversion of the optical activity upon hydrolysis. Thank you so much.